So yeah, feel free to download the data set and you can just use that code to read the data set, and then we'll get started. So let's run a poll, or people can just put in the chat. How many people knows customer lifetime value? Knows in the sense that you have worked with it at least once in your lifetime. You can put in the chat, or you can unmute yourself and you can let me know. I think I should be creating a poll. Yes. Okay, Nicole, don't have any experience with it? Cool. Or no? So the question is, how many people have worked with customer lifetime value before? At least once in your lifetime, let's say. Okay, heard the term, never used it. So we have the poll. You can say yes or no. No if you have, just heard it, but never actually done anything. Yes if you have worked with it. Okay, looks like a lot of people have not worked with it. So that's going to be something new that you're going to work with today. I'm not an expert either, but yeah, I'm a data scientist, so I work with various things. One of them is customer lifetime value. So that's what I'm going to be sharing with you guys today. Okay, I think let's get started. So I'm going to share my screen. We'll give you a brief info about who we are, and then we'll get into the theory a little bit, and then we'll start coding. And if I'm too fast, just let me know. I can slow down a bit. I just have a habit of talking a little fast. And if you guys cannot hear me properly, let us know as well. I'll try and speak louder. Okay, so yep, welcome everyone. So this is I think third masterclass that we are doing, a series of masterclass where we're putting together a data science portfolio, and we're creating 3 different projects to put it on our portfolio. Okay? So for people who are joining us for the first time, this is what we did in the very first session. We learned about how to create, this README file for your GitHub. So whenever a recruiter, let's say, lands on your GitHub page, they'll be able to see the information that we provide to them. The other thing we did was we started creating this portfolio, right? So we updated a bunch of things on here. The services that we offer, let's say the projects, we are going to update it at the end. So we're going to do 3 projects. So this is our second one. Then you update about yourself, right? Your entire timeline, experience that you have. If you work as part of a team and so on and so forth, you can update that as well, right? So again, we'll come back to this portfolio at the end. So this is going to be after 2 sessions from now, I think. We'll come back to it and we'll update it. Okay. So today we're going to be working on the customer lifetime value. Okay. So who we are Data to Production. So yeah, I should started this thing months back. Now we have a team with a couple of more people. So what we offer is, we do podcast series for beginners, so people can, come and attend, interact with the data scientist, ask questions, and so on and so forth. We offer end-to-end mentorship program. That's at the industry standards. So you would build an entire pipeline as you would in a company. That's what we offer, and then we offer 3 master classes on various topics. So Ashit, you want to introduce yourself quickly?
Hi everyone, my name is Ashit, and I've been working as a data scientist for more than 2 years now, and currently working at IDFC First. And feel free to connect with me on LinkedIn. Thanks.
Okay. And about me, I'll just quick, I'm a data scientist at Decathlon Canada. I have 3 years of experience as well. You can connect with me on LinkedIn as well. And the other thing that I want to share is our website where you can find more information about us, as well as the mentorship program that we offer, beginners, intermediate, and advanced. We have something exciting to announce today for the beginners. We'll do that at the end. And you can find about the team here. We have a couple of people, Pradeep and Shashank. Shashank's a data scientist at Geo. Pradeep's working with us as a marketing analyst. Okay, so let's jump right into the topic, right? So the topic today is customer lifetime value, right? Now I work in retail, right? I work with Decathlon, which is the largest sports retailer. So we have tons of customers, right? So when you have tons of customers, you really want to understand your customers, right? Because you want to generate more and more revenues. You don't want to spend a lot of money on acquiring new customers, right? And the customers that you already have, you want to create some value out of them, right? So the whole point of customer lifetime value is basically understanding the customer's purchasing behavior, right? How much has customers spent with us in the past? How much will customers spend in the future? Which customers are valuable? Which customers are not valuable, right? And the customers who are valuable, are they spending enough with us? If not, is there something that our marketing team can do so that they can spend the amount that we want them to spend with us, right? Maybe offer discounts or provide some promotions and so on and so forth. So customer lifetime value sort of helps capture all of those sort of things. And rather than going, companies spend a lot of money, right? So I think I read an article somewhere where it was mentioned that in the past, I think 6 years or 5 years, I don't remember exactly the timeline, the e-commerce companies have spent more than 222% of the revenue on just acquiring new customers. So this data now is oil, right? So you can use data and the customers that you already have, right? And you can cut off the cost that you have to spend on acquiring new customers. So that's what we're going to be doing today, and how to do this in Python, and that'll be the key. So yeah, 2 things to keep in mind. One is historical customer lifetime value and the predictive customer lifetime value. So historical just meaning the customers that have spent with us for a given amount of time, and how much these customers will bring value in the future. So I think that's what I've been talking about, mumbling about. So customer lifetime value is a measurement of how valuable a customer is to your company or brand, right? And not just on purchase by purchase basis, but the entire relationship with your company or with your brand, right? If this customer has been with you for 2 years, how valuable is that customer, right? In that entire 2 years period. And as I said, right, it saves businesses a lot of money, right? Because they can cut off the amount of money that they spend on marketing. They can also prevent customers from, right? Because the valuable customers, you don't want to lose them. You don't want those customers to go to other brands, right? You want to keep them. So it helps to prevent customer churn, and it helps find best customers, right? You have bad and good and bad customers in terms of how much money they're spending on your brand, right? So these are all the things that helps you guys, and there are many other things that you can find on the resources. Is everyone clear so far? Yes, then. So yeah, we'll be sharing the slides with everyone, so you'll have access to the slide.
So any questions, anyone, about what exactly is lifetime value?
Yeah, how to do the analysis, I haven't got there yet, right? We haven't got to that point. So all I've been doing is explaining, why customer lifetime value is important and what it is. Okay, no questions.
So basically, what is a lifetime value of a customer? So let's say you own a shop and you have multiple customers. So just pick one of the customers, and if you can figure out how much business will this customer give to you, that is that customer's lifetime value. So that is basically it.
And we'll see numbers, right? Just to make it more concrete, we'll see some numbers on how to do this. So it makes sense. Okay, so let me move on to the next step, right? So there are many different ways. So are we talking about monetary terms only? Yes, we're talking about monetary terms only. Business gives through lifetime. Yeah. If the customer is new coming for the first time, in that case, what you do. So if the customer is new, you don't have the history of how much the customer has spent money with you. So all you can do is you can keep track of those customers for a period of time, and then you'll know how valuable that customer is, right? So again, everything is related to data, right? So if it's a new customer, you don't have any data for that customer, right? So you don't even know if that customer would fall in a good category or a bad category, right? Until they actually start spending some money in your company or brand for a certain period of time. Right?
So one thing businesses can do is they can cluster the customers into different groups, right? So so let's say you track the spending habits of the customers and cluster them into different groups, and you can make some other assumptions that the people who have similar spending habits will have similar behavior and hence a similar lifetime value. So if for new customers you can do something like that, but it is obviously an approximation.
Yeah, and that is all customer segmentation, right? So that's another topic, which we can spend an entire session on, maybe in future. Right. So segment how to do clustering, how to segment customers in different groups and so on. Right. But not today, though. The sole focus will be the customers who we have the data for, right? So we have the data for these customers, and we are only going to be focusing on these customers. So that's what we're going to be focusing on today. So there are many different approaches in calculating customer lifetime value. Now, one of the simplest approach that you could think of, even if you're in sleep, is basically, how much average revenue per purchase. So, right, on average, how much I'm spending, right, in your company, in your brand, right, and how often I'm purchasing from your brand, right? So I can multiply those two numbers, and how long I've been a customer of your company, right? So as an example, I'm going to take an example of Decathlon because I work with Decathlon, right? So let's say I take an example, right? So if I'm spending $40 on average at Decathlon, and let's say for a period of 10 years, right? So if I can multiply those two numbers, so that's like $400 to Decathlon. That's how much I've been spending in the entire lifetime that I've been a customer of Decathlon, right? So that's another way of computing customer lifetime value. Now, when you compute customer lifetime value, there are a lot of factors that you have to take into account, right? How much money you went into acquiring those customers, and there are a bunch of other factors, right? So this is the simplest one that I'm use the very simplest approach, right? Just like in machine learning, you always start with the simplest model, right? So you just to get the baseline metric. Same thing here. You always start with the basic analysis, then you add on complexity to it. Okay. So we are going to approach from the ML perspective, right? Because you're looking at data scientists who are doing machine learning, right? And we're gonna try and see if we can use machine learning rather than using traditional approaches, right? So how do we do that? Well, there are 4 different steps that you can do, right? So starting with the first step, you find group of customers who started purchasing at the same time, right? So you don't want to be biased, right? You don't want your results to be biased and so on, right? So you're going to start at the same time. So you're going to group all the customers who started their journey around the same period of time. That's the first thing. Okay. Then you do a time series split. Okay. Now, one thing to remember about customer lifetime value is this is not like the machine learning, the time series forecasting thing we do, where we have a data, let's say up until now, we split it into training and tested, and then we predict or forecast on the future data. That's not how it is with the customer lifetime value. The way it works with customer lifetime value is, so I have a data from, let's say, January up until this month, July, right? So what I'm going to do is I'm going to take the entire data from, let's say, month 1 to all the way month 5. That would be my historical data. And I'm going to predict for month 6, right? For month 6, I already have the customer's data. I know how much my customers have spent with my brand, but I'm going to use machine learning, and I'm going to see how much my algorithm is saying the customer should have spent. So that's how the customer lifetime value is calculated. It's not forecasting or making future predictions. So keep that in mind. So when I say time series split, all I'm doing is basically, in this example of month 1 to month 7, I'm taking month 1 to 5 as the historic data, month 6 as the future data, if you like, as well. Right? But remember, it's all historic data. Now compute RFM. Now, how many people know what RFM stands for? Put in the chat. So if you have read about customer lifetime value before, what does RFM stands for? Anyone? No. Okay, so R stands for recency. Okay, so recency is basically when the customer made a last purchase. Okay, F is for frequency, so how often customer is spending with us. Okay, and M is basically the monetary value, so how much the customer is spending with our brand. Okay. So this is what we compute. So this would be our feature engineering. Okay, and then we apply ML. Right? Now, there are two things we can do with ML. We can do a regression as well as classification. Okay, so a regression would be how much customers will spend in the next N days, right? So going back to the example of this year, so I want to know how much the customer will spend in the month of June. So that's 30 days. Okay. And then the other will be the classification, right? So I want to know, with certainty how much the customers will spend with us, right? So a customer 1, let's say I have 90% probability that this customer will spend $200 in the month of June in that 30 days. Okay, so that's what.
Did everyone understand what is RFM? Any questions on this?
Is everyone clear on RFM? What does it stand for? Okay, you guys need to interact, because the only way I know you guys understand is if you guys interact with me, right? So take advantage of this. This is free. You're not paying for it. Right? So take advantage of this. Okay, good.
You do use the reactions. So Zoom has reactions like this.
Yeah, that's pretty cool. Except I can't save them. So yeah, you can put it in the chat. It's fine. Okay, and we'll come back to this again and again, guys, because we're gonna go through this step 1 to 4. So the data set, okay, so the data set, so if you want to read more about the data set, you can go find this article. So I've taken the data set from this article. It's CD Now data set. So what is it, right? So it contains the entire purchase history up to the end of June 1998. Okay, so there are about 23,570 customers who made their first purchase in the quarter of 1997, and there are about 70,000 data points that we have, and it consists of customer ID, the transaction date, and the number of CDs that the customers purchased, and the dollar value of the transaction. And then we have about 2,357 customers. So we can go and read some details here if you like. I'll put the details here as well, right? So 66K purchase history, so that many transactions for 25K customers, 19 different products. So we have customers who are active as well as we have customers who are inactive. So good and bad customers. Right? So that's what the data set is. You'll find some resources. These are really good resources. I would encourage you to read them carefully to understand more about personal outcome value. Again, like I said, I'm not going to be sharing the code with you and the notebook with you because I want you guys to code with us. Okay. The data set, you will find it here. Okay. So if you go on here, you'll find the data set. So just download this. Okay. So you can just download it here. And then I sent you the code in the chat, which I'll do again for people who just joined. So you can use that code just to read the data. Because the data is in a different format. Okay, everyone good so far? Any questions? Because we're gonna move on to the actual code. If you have any questions, send in the chat. I'll wait 20
They'll have to
seconds.
upload. They'll have to upload this to their own drive, right?
Yeah, you can. I mean, you can just download it and just change the path to read CSV, or you can upload it in your drive.
They're coding it in their local, so they can just down.
Yeah, you can
So-
just download it. The easiest would be to download and upload it.
So where's the link of the data set? Can you send the link?
Oh yeah, sure. Oh my bad. Yeah, I didn't share the
Yeah.
slides with everyone, right? So
So everyone just download this data set, and if you are coding on your local machine, then just use that. Otherwise, if you are using Colab, then you can either just upload it directly onto Colab or upload it to Drive and then access it via Colab.
if anyone new to Colab, this is how you use it. So just type Google Colab. This is where you end up with. You need to be signed in, and then just do new notebook. Okay. And then basically you come on this side on the folder, you just go to this upload and you just upload the data set. Simple as that. Okay. But if you're new to Colab, that's how you do it. So I'm gonna get started. So we're on time. Okay, so let's get started with the actual analysis. Can you guys see the screen properly and the code? Or do you want me to zoom in?
Yeah, can you zoom it
Zoom in. Is it good or more?
little more?
Good? More. How about now?
Yeah, that's good.
Okay, so let's get started. So we're gonna start with importing some libraries. Okay, so what are we gonna use? We're gonna use Pandas, NumPy. Some of them I'm not using it. It's there because I was doing some stuff on there. Then we're gonna use XGBoost. You can use any other algorithm. I'm not gonna go through an explanation of XGBoost. Now we'll take another session. But yeah, so I'm gonna be using the classifier as well as the regressor, because remember we're doing two things. Right? So today you're learning about classification as well as regression. Okay. Now the data set, because it's on my drive, this is how I mount my drive, and then I can read from the drive. Okay. So I'm just gonna go ahead and run the code. Okay, so I mount to my drive. It's gonna take some time. Okay, done. Let's look at the data set. Okay, so what do we have? We have a customer ID, we have a date, we have quantity, and then we have the price. Okay, so quantity is basically how many CDs in this case the customer has bought. Okay, so what do? The first step, data scientist, right? So the first step we do is we make sure the data types are right. So I'm going to do data info, and I'm going to check the data types for each one of them. And I can see it, this is customer ID is an integer, date is an integer, so I need to change the date. A quantity is an integer, that's fine. Float is a price, that's fine because I have decimals, right? So far, so good. So let's do some data pre-processing. Okay. So I have the date time column, which I need to convert into from int to a date time. So I'm just going to use pandas. All right. The first thing I need to do is convert it to. I tried directly doing it just without converting to string, but it didn't work because it's an integer. So I have to convert it to string, then I have to convert it into date time. So that's how you do it.
So we are just
Okay.
making the data into a usable form so that we can actually use it and make some features and put it into a model.
Yeah, exactly. And there's not a lot of pre-processing to this data splitting, right? And because the session is small as well, so try to keep it clean. Okay, so let's see, from when until when we have the customer's data, right? So we see that the data actually starts 1st of Jan of 1997 until 30th of June 1998. Okay, so we have a good amount of data. Okay. Now, like I said, right? So I'm going to go back to the slides. I'll have this open on the slide, right? So I said, find group of customers who started purchase at the same time, right? So that's what we're going to do the first thing, right? So first thing we want to do is we want to find the first purchase of each customers, right? So what do you have to do? I have to sort by the customer ID and date, right? Because again, I want to do it for each customer. Now I might have duplicate customers here, right? Like you can see that here out of it, right? Because they're making transactions on, let's say, different days or different amount and so on and so forth. Or they're making transactions in the same day, but they're paying it. They're not paying it in one go. Right? So I'm going to sort the value by customer ID and date, and then I'm going to group by the customer ID. And then this Python has this nice function called first. So you just do that, and it will give you the first purchase of each customers, right? Now I'm going to look into the data frame. Let's see what's the minimum and maximum. I can see the minimum is exactly matching with when the data started, or when the company started collecting the data. And the max is basically at 25th. Okay. So during these period, so in this date range, we have the first purchases made by 23,000 customers. Okay. So it's good to verify this as the first step. Okay. Then we move on to feature engineering. Okay. So what's the next step we have to do? The next step we have to
Any
do
questions
is,
still here?
yeah, up until this point, I didn't do anything new. If you guys have any questions?
So what all we did? Can we summarize it? Can you go to the top? So we are just reading the data, then converting some columns into usable forms. So like converting the date column, checking the date range, what is the range of the data, then aggregating the data by customer ID and date. Then
That's
that's it.
about it.
That's it. That's all we did.
So we didn't do a lot of things, right? Now we're gonna do a lot of things. Okay. So feature engineering, right? The next step, time series split, right? So we want to split the customers into historic and the next n days, if you like, right? Which would be our future data. You can think of it as future data. It's not really future data. Okay, so I'm gonna take the 30 days. Okay. So I want to predict using machine learning. I want to predict how much the customers would have spent in that 30 days. Okay. So what I'm doing, I'm just taking, just assigning it to a variable. I'm taking my max date from my data, and I'm just subtracting away 30 days from it. Right. So I have the data up until this point. So that's my cutoff date. So I have the data from the 1st of Jan 1997 up until 31st of the 5th month 1998, and then I have the 6th month. It would be my future data, for instance. Okay, so far it's clear. Okay, I'm guessing so far it's clear. I did have some code on how to use. So are you guys familiar with PD dot 2 time delta? How does it work? If not, I'll go through it because I have some examples here. Just let me know in the chat quickly if you guys are familiar with it.
The time delta function.
Okay, no? Okay, I'll go through it quickly. Okay, so how does it work? So I have an example here. Okay, so I'm just creating some dummy date. Okay, and then what I'm doing is I'm taking the current date time and I'm going to subtract the 2, right? So I get the time elapsed, right? That's what it gives me. And then if I just do dot days, it tells me exactly, how the time period between the two. How many days between, the last purchase date and the current date. That's what it tells me, okay? Using dot days. Okay, so this is one way of doing it. The other way of doing it is using the time delta. So what the time delta allows you to do is basically it allows you to convert to days, but in numeric format. Okay, so again, this is the same code as above. Okay, so this exactly is the same code as above. But this time, what I'm going to do is instead of doing dot days, I'm going to use PD dot 2 time delta. And I'm going to pass in the unit here, D. D is for days because I want it in days. I can do months, I can do weeks, I can do years, and so on and so forth. Okay, so all I'm doing is I'm taking that time difference, I'm just dividing it using this function so that I get the results in days and in numeric format, right? So now you can see here, this was an integer, right? So I'm getting in the float format. That's all that function does, nothing else. Okay, so again, you can do it this way, which is really simple to understand. Again, if you want to use some fancy pandas functions, you can do it this way. And this one gives you in the float format rather than just an integer. Okay. And I think sometimes it's good that it gives you in the float format because you could have 6.5, or if you end up with those kind of days. Okay, so that's all it does. So I'm going to go back to where I was before here. Okay, so I've defined my cutoff date. Now I'm going to get the historic data and the future data. So the historic data will be everything that's before the state. Okay, that's what I'm doing here. And the future date will be everything that's after the state. Right, so the last 30 days. Definitely. And sorry, you're going to hear some noise because I'm in the kitchen. So I'm doing the session from the kitchen today. So far clear. So all we did was we just split the data into historic and future. That's it. Okay. And then I'm going to do
Let's
some.
take
Yeah.
30 seconds for any questions.
Yeah. So with 30 seconds, if you guys have any questions.
Hi. So I had one question. Unit as a small alphabet, capital D. Does it? It would still calculate it.
This one here, right?
Yeah. I think in the there was a capital D.
Capital D, yeah. So I think it doesn't matter which one do you use, but I'm gonna check.
Okay.
Sorry, yeah. What was the time delta? Time delta. Because I use it interchangeably because I use this a lot. Okay, so we see that we have capital D for days. I think you can use any D, capital or lower, it doesn't really matter. So you know what? What I'm gonna do is go back here. Let's try it with lower D. Yeah, it doesn't make a difference. So you can use lower or capital, it doesn't matter.
Okay. Thank you.
Okay. And then you guys can go here and read the official documentation. You'll see how to extract for minutes, seconds, milliseconds, and so on and so forth. Okay, any other questions? No? Okay, so move on. So now we're gonna do some feature engineering. Okay, so before that, I just want to know, how much the customers have spent in the last 30 days. And I'm gonna flag out those results. Okay, so that I know that these are the customers who have spent in the last 30 days. Okay. So what I'm doing here is basically I'm just taking that feature data column. I'm just dropping off the quantity because I don't need it. You can keep it, doesn't really matter. And then here, I'm just grouping by the customer ID. Okay. And then I'm just summing up, right? So I want to know how much the customers have spent in the past 30 days, right? So I'm just grouping by the customer ID and I'm just summing up. So it's going to compute the total for the price column, right? So we have here price, right? So it's going to compute the total for the price column for each customer, right? So that's what this is going to do. So let me actually show you that as well. So we'll do step by step. Oh, I don't have the code. Okay, so now I can see here, you know, customer 9, customer ID with the 9. Yeah, sorry, customer with the ID 9 has spent $42, around $42 in the last 30 days. Customer ID with the 25 has spent about $50 in the last 30 days, right? So, you know, this kind of helps me to see, you know, how much customers I've spent in the past 30 days. And all I'm going to do here is I'm just going to flag out these customers, just creating a new column and assigning it a value of 1. So I know that these are the customers who have spent money in the past 30 days. And you will see this is helpful when you create a dashboard. It helps you filter out customers who have spent and the customers who have not spent. Okay? So that's why I'm creating that additional column and just assigning it a value of 1. Okay. Now the new data frame looks like this. That's all. Nothing new. Okay. Then I'm gonna take the max state, which you already seen that before, so I don't need to show this again. Okay, so now we come back to the metrics: recency, frequency, and MRR rate. Again, here I haven't done anything new, right? So all I'm doing as a data scientist, I want to know how much customers have spent in the past 30 days. So I'm just doing some analysis. That's all. Okay. Now we're gonna go to step 3, which is RFM. So we're gonna compute RFM. Okay. So let's go to RFM. Where is it? Here. Okay, so recency. So like I said, what is recency? So recency is, find the most recent transactions of a customer, right? So when was the last time the customer made purchase with my company, let's say? Like how long ago was this transaction? Right now, I want to know how long ago was this transaction in terms of dates. Was it 20 days ago, 30 days ago, and so on and so forth. So first, you have to find a reference point, right? So what is a reference point? The reference point is nothing but when was the very last purchase that the customer made? Okay, and then you compute the time lapsed between that last purchase and now. Okay, and then you choose an appropriate unit. Do you want it this time lapsed in days, weeks, months, and so on? Right. So that's what you want.
So would anyone like to answer, like, why does recency matter here? How is recency relevant here in finding the lifetime value of a customer? Anyone?
And there are no right answers, so even if you're wrong, doesn't matter. Just try and attempt to answer.
So we are just trying to create a model here. So we know the objective that we want to calculate the lifetime value, and we want to create some relevant features relating to that, so that we might be able to predict the lifetime value accurately. Yes, someone was speaking.
Yeah, so the whole objective of this is to for the company is to gain insights to increase their business or basically customer retention and reduce the customer churn so that they can make profits and all. So the recency would be important because it, for example, as a customer, I might have bought something from a particular site 100 times, So my frequency is very high, but it might be possible that I might have bought it 3 years back. So, and after that, I haven't bought anything. So to the company, it doesn't matter at the moment that it looks like this customer is not bringing that monetary value to this company in the recent times.
Definitely. Yeah, perfect. Right, Nazar?
Yeah, that's a good answer. Yeah, knowing, yeah, if you have a customer who's been, very frequent, but the amount of money that was, let's say a customer, like you mentioned, let's say, take an example of 100, right? So let's say a customer has been, making purchases 100 times, but the amount of money that they've been spending, it's only, let's say, $50 in a in a time period of 3 years. So a customer's lifetime, let's say it's 3 years. So in that 3 years, customer made, let's say more than 100 transactions actually, and only spent $50, right? This customer, yeah, they've been making purchases, but it's not bringing any value to the business, right? Because the amount of money that the customer is spending, it's only $50, versus someone who's been, making transactions, the same amount of transactions, but has been spending, $500, let's say, right? And also, so knowing, how recent this customer made the purchase and how much, kind of how your model, to better predict, right? So if this customer who hasn't been spending a lot of money made a recent purchase of, a large sum, let's say, $600. Yeah, given that this customer wasn't making a lot of purchases in the past 3 years, but recently this customer all of a sudden spent $600, right? Now this customer might be valuable to the business. So you want to know exactly, how much this customer has spent and how long ago. So does that make sense? Yeah, recency is the reason why you get lots of push notifications. That's true, right? Let's say if you've been an active customer of any brand, and you've been spending a good amount of money with them, they'll definitely reach out to you. Maybe offer you promotion, whatever, right? To keep you spending money.
So Nikhil has a question.
The recency should be less than X days to get active customer list. So the recency, yeah, it should be less than X days. So what we are doing is, how is the recency calculated? Right? The recency is calculated by, taking the most recent purchase and you're just subtracting off today's date, right? So it needs to be less than, today's date. And that's how you're computing recency. Does that make sense? And again, these are active customers, right? So this one, the number itself will tell you whether this customer is active or not, right? So if you get a number in terms of days, okay? So here, like I said, the last point was choose an appropriate unit. So we are doing in days, right? So if we have, let's say, customer ID 9, the days returns 10, let's say minus 10. So that means this customer is active because this customer made a purchase just 10 days ago, right? So you might have customers, whose recency might be, 400 minus 400, let's say. So I mean, the customer was active 400 days ago, right? So you could technically consider this customer to be inactive. So, the customer didn't make purchase in the last 400 days and so on. Yeah, recency tells us the customer's last engagement with the product. That's right. That's the nice way to summarize everything. Okay, does it all make sense? Is everyone good so far? Okay, so let's move on to the next one. Wait, we haven't completed yet. So we're gonna compute recency. Okay, so the way you compute recency is we're gonna use this friend of us, time delta. Okay, so I'm gonna take the customer ID and date, right? Because that's all I care about. And I'm gonna group by the customer ID. Why? Because I want to calculate recency for each customer, right? And then here I'm gonna use a lambda function. Okay, so for each customer, I'm gonna take the maximum date that the customer made purchase. So the most recent date of each customer. Okay, and I'm just subtracting off the max date from my historical data, right? That cutoff point, if you like, right? Because that's where my historical data ends, right? So you can think of max date as today, for an example. Okay. And then this will be, let's say Ashit made a purchase 10 days ago. So Ashit is a customer. When did he made the last purchase? 10 days ago. That's why I'm using max here. Yeah. So that would give me the time lapse. And then I'm using this so that I can get it into proper unit, right? And I want it in days. Again, you can use D, or you can use day, or you can use capital D. All of them works, right? So this would give me the results in appropriate unit, right? So now I'm just going to convert that into a data frame, right? And then set access to recency. This will be named, right? And then this would be my data set. So I'm just going to show you guys what it looks like. Okay, so that's what it looks like. So what do we have? Right. So we have customer ID 1. And the customer ID 1 made a purchase 551 days ago. Okay. So this could be an active customer. We don't know how much the customer has spent with this. We'll know if it's a good or bad customer. Customer 3, the last purchase was just 3 days ago. And so on and so forth. Does it make sense? Right. So that's how you read this data frame. Okay. So let's move on to the next step. It's very short on time. Again, stop me if you have any questions. Frequency. So frequency is how many times did the customer make purchase, right? So how often Ashit is buying from my company, right? So to do that again, this is the same stuff as before, and all I'm doing is count, right? And then I'm just going to rename it to frequency. That's all. I can see here, we have customer 5 made 11 transactions, let's say, customer 4 made 4 transactions, and so on and so forth. Does that make sense so far? Okay, nothing fancy, right? Get used to this code here because you get asked a lot in interviews. Okay, I remember it was a shame for me, but I remember a while back I was doing an interview with IBM for an entry level role, and they asked me this exactly. They were like, "Okay, get me the data frame like this." So all I had to do was this, but I wasn't active in Python, right? I was more into R, but they didn't let me do an R, so I did not do in Python. But again, you get asked in interviews, so get used to this part of the code. The rest of them is just aggregation, right? Whether you want to do sum, mean, and so on and so forth. Okay. And the other thing you should get used to is using this set access, right? Because oftentimes you get asked in interviews, this name here, if you don't use set access, it will be something else. It could be count. So how do you change that? Right. So practice, keep practicing. Okay, now we're gonna look at how much money the customer has spent. That's the last thing in RFM, right? So we want to look at the mean price as well as the total amount. Okay. Again, doing the same thing. Just group by customer ID. And now I'm using this .ag because I'm computing a couple of metrics, which is the sum and the mean, right? So this is how you do it. You just pass the dictionary to this ag, that's all. And then you rename them. So rename the columns, price and sum. Okay, so customer 1, the total amount that spent with us is $12, let's say. The mean is the average amount that spent with us is the same. This customer here has spent $89 so far. And the average per transaction was about $45. Does it all make sense? No questions so far? Everything clear? Okay. Looks like everyone's going to be an expert in customer lifetime value after this, since no questions. Okay, we're going to combine everything together. Okay, the recency, frequency, and the price. So I'll just combine them all together. That's what it looks like. Okay, and then I'm just combining this with the target. What is our target? Where do we have our target? Let's see. Do you have it on anywhere? Target, yeah, this one here. Right, so long back we created this data frame to see how much the customer has been spending in the last 30 days, right? Again, remember, this is our future data to like, okay? And all of these things that were computed are the historical data. So we're just going to combine them together, and we'll just fill in the missing values in it with 0. Okay. And that's for the entire data from this side. So we have recency, and how do you read this? Customer 1, the last purchase, the last transaction they made with us was 551 days ago. How frequent have they been? They only made one purchase with us, one transaction with us of $12. The average sub spend with us is $12. In the last 30 days, did they make any transactions? Nope. So the flag is 0. Okay, does it all make sense? Let's find the one. Oh, that's going to be too long to view. Okay. Oh, okay. You can see the okay, let's do ML. Questions. Does any term from RFM show us the cyclic purchase of customers? Say sales of the card, which happen a few times a year in a year. The sales, I don't think it shows, it gives you any trends that's happening.
So in these 3 features, there's no feature that tells you about the cyclicity of the purchases. So
Yeah.
if you want to consider that, you'll have to create a new feature.
So for that, what do you need, right? So you often do that in time series, right? So you look at, you plot the sales versus time, right? So, and then you look at the cycle, right? So in this case, we don't have, I mean, in this data frame itself, we don't have any of that, right? So recency, frequency, the total price sum doesn't tell you anything, right? And again, remember, this is for each customer. Now, this customer, it's not going to be, some customers might be with you for a period of a long time. Some customer might be with you for a period of 10 days and so on. So it doesn't really tell you the entire cyclic nature of customers. But yeah, you can do a little bit research on that. That's a good question. But
So
as of this, I don't see how.
One part of cyclicity is frequency, obviously. But frequency does not give the whole picture of cyclicity. So you have to include the duration between those purchases as well. So combining the duration between purchases and the frequency, you can get the cyclicity.
Good question. Any other questions so far before we move on to exciting stuff, ML?
Does that answer the question, Nikhil?
Okay.
Cool.
Any questions? So this is the entire data we're going to use right now. Any other questions anyone has, or should I move on? Okay, so I guess I'll move on. So what's the last step in the process? Apply ML, right? So we are doing regression as well as classification. So let's take the features: recency, frequency, price sum, price mean. Okay, so we're taking all these features, right, into X. And why am I not taking this? Can anyone answer that? Why am I not taking spend 30 days and spend 30 days flat? No one wants to answer it. Okay, I'll leave that as a surprise to them. So what is my why? My why is spend 30 days. That's why I'm not using it. Okay, nobody gave me the answer, but no one answered. So yeah, so that's the feature that I want to predict. Right. So we have X and Y, and I'm not going to do hyperparameter tuning or the stuff here. It's just a base model, remember. So we are working on MVP, minimum viable product. Okay. So I'm going to use XGBoost regressor. I'm passing in the random state. Everyone knows what a random state is, I'm guessing, and this produces the same results. Okay, so I'm going to put it to the model. And then let's see how good is our model. So the training score is about 87%. Not bad. And I'm going to predict on the X. Okay, so that's what it shows me. Now remember, I'm taking the entire data, right? I'm taking the entire data. And this data here consists of the historic as well as the future. Okay, so that's what I'm doing there. So this would be my regression. And again, you will see how the entire thing looks like at the end. Okay, let's do classification. So in classification, I want to predict the spend 30 days flag, whether yes or no, whether the customer spend or not. Okay, so that's going to be that. I'm going to use the XGBoost classifier, right? I'm going to fit it to the X and Y prob, which is X is same now. The target changes. Okay, let's see, 95%, not bad. And then I'm just going to predict on the entire data set. Okay, so entire data set. So that would be my historic as well as my last 30 days one, but my target is last 30 days, right? So that's what I'm focusing on. So here I'm just combining everything together, right? So I'm just taking the regression prediction and then the classification predictions. Okay, and then I'm just bringing the features from the feature column back, like recency, frequency, the price, the total price, and the mean price, because I want those as well. Okay, this is my entire final data frame. Okay, now I'm going to put this into a dashboard, and then we'll look at the dashboard and learn more about it. Okay, now before that, also I'm missing customer ID. I don't have customer ID here, right? So I'm just going to go and extract customer ID from my raw data, and I'm just going to combine it here. Okay, so now I have customer ID as well, the entire customer ID. Okay, so that would be my predictions DF. Now I would save that to a CSV file. I don't need all of that. Okay, then I would save it into a CSV file. Okay, and then you can use that CSV file into a dashboard. So it is here. Okay, so any questions on the ML part before I move on to show you the results and we talk more about the results? Again, I didn't do anything fancy yet. Go ahead, Harsh.
Just one question. Is the aggregate function which you've used can only compute the inbuilt sum, mean, or count, maybe aggregations, or is it like, let's say I want to aggregate two, while feature engineering, I want to multiply two features and create a new feature out of it. So can I do like something known as, can I do something like
here
quantity into price and create a new feature? Like
I think so. I think you can do that. I have tried it in the past. Yeah, you can't do it.
You have to do it
I
in
don't recall.
steps. So first aggregate it, then do the transformations.
No. Yes.
So let me see.
Thank you.
Okay, yeah, you have to pass in the function then. So you have to create a function and then you can pass it in. That's the other way of doing it. Right here, it automatically considers where to go. Yeah, so you can do sum, you can do mean. I think you can do median, count as well. There are only certain ones that you could do, but if you want to do the custom one, then you have to create a function and then you have to pass it in. Yeah.
Thank you.
Yeah. Any other questions?
So everyone understood this machine learning part, right?
Again, nothing fancy. I didn't do anything fancy. I just took, the model as it is, and I just applied it. Nothing else. Okay, so I guess I'll move on to the results. Okay, so what I've done is I've put it into a dashboard. So again, you're a data scientist, your results need to be used by someone else. Okay. If you're building fancy stuff, if no one is using it, it's a waste. Okay. The product needs to, think of any project that you do as a data scientist as a product, and you have to sell that product. Right? You have to make your users use that product. Otherwise, there's no point building the product. Right. So you turn all the analysis into a dashboard. Okay. And now this one here, I can pass it to the marketing team, or whoever is in charge of dealing with customers, right? And they can use this dashboard to do various other things. Okay. So here, for instance, what do I have? I have a customer ID, I have country, the predicted amount, right? So that's the amount that our machine learning predicted the customer should have spent, and the probability, right? We have the mean price, we have the total price, recently frequency, and the last, in this case, 30 days. Actually, this one here is based off different data set. So it's last 60 days. I mean, it's the same data set, but I've done it for the last 60 days instead of 30 days. Okay. And so these are all the customers who have the highest probability of spending in the next 60 days. Then I have here the customers who spent recently, but has a lesser probability of spending. Okay. And then I have customers who are likely to spend but didn't spend. So I'll split it into 2 different tables for the marketing team. And they have another one, which is, customers who we might think that the model think might spend but hasn't spent in the last 60 days. Okay. So let's look at each one of them. I'm going to select a particular country. I don't care, just to show you how it works. So there are one. Let's see how long it takes. I'm going to pick this customer here. Yeah. So I'll click on that customer. Yeah. And then I can see the country it belongs to and so on. So what do I see? I see that this customer here, our model says that this customer should have spent $1,075 in the last 60 days. Okay. With the certainty of 97%. So very high probability. What is the mean average that this customer has spent in their lifetime? $41. What's the total amount they've spent with us in their lifetime? Pretty high, $8,000. When did they make the last purchase? Just a day ago. How often they've been buying from us? 193 times. And how much they have actually spent? This is the actual amount. And I can see that 1,066, so not bad, pretty close. Right. Now let's find a customer who hasn't spent.
Can you
enough.
zoom in this? Zoom in.
Okay, is that
Yeah.
good? Okay, let's find a customer. Let's find a bad customer. This okay, let's look at. Okay, let's look at this customer here. So this customer model thinks $87. So our model is doing a pretty bad job here. A probability of 56%. So yeah, the probability is low as well. So the model is doing good because it says it's only 56% probability that the consumer might spend this much. The mean amount and all that stuff, the actual amount is $205. So you can see that the model said, with certainty of about 60% that the customer might spend $87, but in reality, the customer spent $225. So that's how you read that table. And then you have this table here. The customer who spent recently but has lesser probability. You can see all the probabilities are pretty low. But if you find a customer who ended up spending quite a large sum, then that's a valuable customer. Like we took an example earlier, right? The customer who only spent $50 in the past 3 years, but then all of a sudden that customer spent $600 in just a day ago, right? And then you're gonna keep track of that customer for some time. Then we have customer who are likely to spend but didn't spend, right? So we have all of these amount that the model says the customer should have spent, but you see that they didn't actually spend anything. Right? So we can then, go and target some customers. We can see, why they haven't spent. That's what the sales team do. Follow customers, get their feedback, see what's going on. Is there any way we can improve the products? Or there's something we could offer them, and so on and so forth. And the likely of spending for customers who didn't spend in the last 60 days. Yeah. So that's that, and I think that's about it. So that's how this dashboard would be used by the marketing team to follow the customers and then help company grow and generate more revenue. Questions? Did you guys find this useful? Was it worth your time? And yeah, we'll update the portfolio and all that after. So we're gonna do one more project next weekend, hopefully, and then we'll do another session to update the entire portfolio. But as of now, any questions that we're done today? So I'm gonna stop sharing my screen so that I can see if people have any questions. Okay, yeah, we're open for discussion and questions. So feel free to unmute yourself, ask questions or whatever.
So, which part of this project was the toughest to understand, or the most unfamiliar for you guys?
And again, people don't drop out. We have an exciting news to share as well. So about the big news. So you'll speak through that as well. So how do you decide what to display on the dashboard, or does the marketing team decides what they want? So it's a combination of both. So I build a lot of dashboards for the marketing team and my company. So it's a combination of both. Because the marketing teams are the ones who directly sort of, are at the end point of interacting with the users. We as a data scientist, we don't directly interact with customers, right? All we do is we understand customers from the desk, right? That the other people who are upfront and interact with customers. So it's a combination of both. Part of, we use our intuition. We see which metrics are relevant, which metrics would be useful to customers, to the marketing team, right? So we put our own, and we bring in our own inputs. But at the same time, we also take some inputs from the marketing team, see what kind of metrics that they are interested in seeing, right? So the way to do it is, you do your analysis, right? So right now, that's what I did, right? So I built an MVP product. I didn't spend a lot of time on machine learning, right? So I built the baseline model. I quickly put together a dashboard, and you even saw that, the dashboard here was a little messy, right? I mean, so here I kind of updated the theme and all that stuff because we're presenting today. But here you can see that, I didn't even bother putting in the boxes and all that stuff, right? So slightly messy, right? So you put together a quick dashboard, and you share it with the team, with the marketing team, get that feedback, and based on the feedback, you then add other things to your dashboard. So that's how usually how it's done. That's how I've been doing it at my company. We have a really big marketing team, supply team, and all that. So I build tons of dashboards. But yeah, that's how you do it. Hopefully that answered your question. But yeah, you as a data scientist need to know some key metrics that you should be providing, some key KPIs that you should be providing to the team. Yeah, any other questions? Any other questions? And you saw that, machine learning is only a small aspect of the entire project, right? It's like people jump onto machine learning and, they just want to do machine modeling, but it's not always modeling. So modeling is only a small aspect, right? Doing the actual analysis, understanding the actual customers, spending time on understanding the data itself, and then understanding the end results. That's more valuable. Like machine learning alone is not valuable. You need to understand the entire process and build the entire tool, right? Like this tool here right now that I've built, right? So this is a one-time thing. Now let's say the data that I shared with you guys, let's say that data, it's a real-time data, which gets updated every week. Then this entire analysis, I'm not going to run Google Colab every single week. I'm not going to sit at my desk and run the entire Colab every single week and keep updating this dashboard, right? What would I do? I would automate the process, right? That's where, again, your new skills as a data scientist is helpful to the organizations to automate the entire process so that you would run automatically every week. And all you have to do is monitor it, see if everything is working fine, if everything, the results are making sense, and so on. Like for instance, like this morning, sorry, I do some kinds of forecasting for my company, and this morning, I got told by stakeholders like the recent data is missing, so the entire last month's data is not there for some reason, right? So you gotta keep track of it every week. Now I wasn't keeping track of it every week because I had other things to do and I was away from work, right? So you have to, even though it's in automation, you have every single week you have to monitor it, see if everything's working, the data is getting fed to the dashboards, the data is getting uploaded to wherever on the cloud server, and it's reaching out to the stakeholders and they're getting the right information. So these are all the key skills as a data scientist, not just machine learning. Okay, the country feature is not mentioned in the data you provided, but the analysis part you mentioned the country. Is there some of the data set? Okay. Yes, actually, yeah. So we combine this data with some other data. So let me talk about that. It's a good point. Yeah, so this data set here actually doesn't have the country feature. That's true. So we provide this mentorship program that I mentioned here. So this data set, along with, we created some of our own data sets, and then we, for students, to help them learn the entire process of how to use databases, how to do ETL, how to clean data set and all that, right? So that's why it's not there in the data set that I provided to you. Originally, it's not there in the data set anyways. Just that we have a bunch of other data sets, and it's we have tried and made it a messy data so that our students can work on cleaning that data and put together everything in a nice format. Yeah. Okay, any other questions? So going back to the topic that I was talking about, and that's why we have built this entire pipeline like you would in an organization. You use a bunch of tools like CI/CD pipelines, GitHub, Jenkins, the CI, Airflow, and so on and so forth to build that entire pipeline. And we just do monitoring of the dashboards at the end. So the exciting news is this. So we have beginners, intermediate, and advanced that we are offering at a much lower rate than other boot camps. Because I know boot camps offer charge a lot of money. For the beginners one, we have decided to start a batch. We haven't decided the date yet. So we are starting a batch for the beginners. So people would like to enroll and learn. And what we would be doing is basically we're building this entire pipeline. So me and Ashit will walk you through how to build this entire pipeline, how to use the different tools mentioned here, how to do, best coding practices to follow. How do you move away from Jupyter notebooks to scripts? Right? So all of those sort of things we'll be teaching in a batch, right? So as many people would like to enroll. It's going to be a live session on the weekends, Saturday, Sunday, for an hour or two, and we build the entire tool. For how long? Well, the timeline we haven't decided yet. It depends on how long it takes to go through the entire process. This is something that we're doing for the first
So,
time.
I've started a
batch.
poll on this only about the batch. So feel free to answer the poll.
And yeah, so for the timeline, we haven't decided. It depends on how long it takes to go through the entire thing. Because up until now, we've been doing this on a one-on-one basis. I mean, in the shape where training students like personally, not in a group. So for that, we had a timeline of 2 months, but now we are opening up for a batch, right? So it's not a personal one-on-one. I mean, if you'd like to have a one-on-one, you're free to join. It's just at a higher rate as compared to a batch. So yeah, so feel free to let us know. In terms of price, I should mention that actually until after we're done with the poll.
So I'm putting in the email also. So in case you are interested in the batch, reach out to this email and we'll get back to you.
Again, the way the bat's gonna work is the way that we did today. Right? But yeah, it's gonna be a step-by-step process to build this entire pipeline. So yeah. And in terms of, if you want to know more about it, if it's worth it or not, you can ask Pradeep, because Pradeep was actually a student of us before he joined us. So the other thing we do is like people who join us, because I know freshers require internships, right? And it's hard to find internships to freshers. So what we try and do is, if you're joining us, we provide like you would come and work with us for a period of 1 month. Obviously, we won't be paying you because you're not a company, let's say, right? So you're just a data scientist who is helping others, trying to train others and upskill them. We are not promising any jobs either. We are promising skill sets rather than jobs. Like other boot camps who promises jobs, but people still struggle for jobs. So yeah, we are not promising jobs, but what we are promising is you learn how to use each of these tools, and you learn how to be a better coder, better programmer, and a better data scientist.